Oops. Adjust my mic. In this tutorial, I wanted to discuss a few things. One was the difference between using quotation marks and this bracket to include .h files, or whatever text file you're including that has code in it. So when you're using brackets like this actually references it from the operating system root. So like you've seen before, I had something to the effect of like that, right? So when you use double quotes, it does it in relationship to where the project is. So the G++ compiler I'm using will look in the same directory as the file that's being compiled when you use double quotes. So when you're doing it like this, using double quotes, all you have to do is just name the file. And this will look at the operating system root level. And these work because these are already defined in the path of the operating system, because the G++ compiler is on the path of my Windows operating system. And both have different uses. Like, these are normal to have in a program. These become standard in every program you would write. And this, being as it would be custom, you might want to reference it differently. So another thing I wanted to go over was the scope of functions. We kind of seen before we couldn't use a function until we defined it up here. Well, one of the things we can do is prototypal development of functions. So I'm going to get rid of this include by just commenting it out, and I'm going to copy this function and I'll paste it down here. And you'll say, well, that doesn't work, James, we already know that. True. So we're going to make a prototype by just copying the signature and then placing it right here with a semicolon afterwards. So this just defines what the function is going to return, the name of the function, and any parameters it's going to take in. At least their data types anyway. Your functions can return any type of different data, including nothing, which would be void. So using this should now compile, because we define the function, and then when it calls the function, it's actually going to call the one down here, because this prototypal function is actually going to reference this, or at least some implementation of that, depending on what parameter it is. So I'm going to save it, open my command line, and compile it, and it compiles. And I'm going to go run it, and the results of the function is 1. So let's make another function that returns nothing. Void, and we'll just print a circle or something. Print circle. So that's the name of my function. It won't take in any parameters, or let's go ahead and take in a few parameters just to show how that works. So we'll take an int. We'll take a character. We'll take a character, and let's take a bool. So those are some data types we know. Then we'll implement them down here. Void print circle, and then the implementation will do that here. And you might be asking, why is this useful? Well, this is useful because now you can have all the functions that you're going to define in like a file, and have separate implementations for all those functions in different programs. So you can collect all these functions that you normally write, and then say you want to print a circle, but in one program you actually want a bigger circle, like what's the diameter of the circle, but in another program you want a smaller circle. So you can put all these into a .h file, and then in each separate program you can write different implementations of it. And that type of code reuse is very powerful, especially when you get into large programs and you get into like ETL work, where you're taking data from databases and moving it from one place to another and doing simple things on that data, and we're getting statistics. So let's go ahead and call this function. Cout. And we have to get an integer, which would be 2, a character, j, and we have to get it a Boolean variable, so we just give it true, just to satisfy the parameters that we were supposed to give it. And then we have to write the implementation. So this is going to accept the int, and then you got to give the integer a variable name. And then there's going to be a character, and then b, and a Boolean variable, and we'll just name it c. And I'll just make a very simple circle here. And let's see if I can do that. This won't be perfect, but you'll get the idea. Okay, so that prints a circle. Does nothing with the variables. We can see out them just to be consistent, I guess. A, B, C. Now we'll compile the function and run it and see what happens. Looks like it had a problem. Lots of problems. What happened? Where's the beginning of the problem? No match for operator, this thing. Ah, yes, because this is returning void, it's not doing anything. So because this doesn't have a return type, this operator can't work on void. So we'll just get rid of this, and we'll hit we'll cut this out of here. I'll hit enter, and then I'll just call the function down here. Save that, and then oh, I just closed my terminal. Darn it. Well, I do have this fancy thing open in my editor where I hit Control-Shift-B, and then it compiles below, and this still has an error. Can you tell me what the error is? No, it doesn't. Let's see here. Print circle, character, Boolean, void. Okay, that looks good. Not sure what the problem is. Alright, we'll have to open our command prompt again. Users, my name, and we'll have to look for desktop, C, C++, and then G++, miles.cpp, and looks like it's working. So something's wrong with my editor there. It doesn't like my file for some reason. Oh, you know what the problem is? I was supposed to right click on this and compile and run. There it goes. Honestly, I like my terminal actually a little bit better. Okay, So that's running our basic function, and there was another thing I wanted to go over too. Well, we got the H file working, how to do it relative to your project, and then we went over how to do prototypal function development, and then implementing different things. Let's implement a different print circle. So I'm going to copy this function and put that here, and instead I'm just not going to take in any parameters. Now, because this signature is different, this whole thing I highlighted here, because that's different, this is now an entirely different method than this one with parameters. So I will also have to put that up here. So now that is also defined. So now we have like two implementations of the same thing, except one takes in parameters and one doesn't. So let's go ahead and call the other one, but we're just not going to include any parameters in it, and we'll compile this. And then I have an error here. Let's see, it doesn't, we don't have any parameters, so nothing to see out. So that compiles. And now two circles print. Cool. So that works. So that's kind of that's known as overriding functions, which means that you use the same name, however the signature is different. So you have different implementations of the same thing, given different information. And thank you for watching. Stay tuned for more C++ stuff.